I never tire of learning or teaching. At Ball State, we're encouraged to work closely with students. That's the best part of all. There's nothing better than seeing a student grow.
Dr. Carolyn Vann is a respected professor and DNA researcher. Academic excellence at Ball State University.
Oh, what a difference you make in my life.
We are here in a really cool place. We're at the Space Center Houston and Johnson Space Center, and we're going to have a fabulous show for you called Journey to the International Space Station. And with me is Joy Peterson, who is going to kick us off and launch us on our journey. So, Joy?
Well, hi, everyone. My name is Joy Peterson, and I'm the lucky representative of Best Buy today. Our company has 800,000, no, not that many, 80,000 employees across the country who are excited to sponsor today's visit to the Space Center. I'm sitting in something called the Manned Maneuvering Unit. It's one of many exhibits that you're going to have a chance to visit today. Best Buy supports educational outreach programs that are involving technology in life. We think the Houston Center is one of the most exciting science educational venues in the country. So please enjoy today's activities. Make sure you use your email and use your telephones. Call our scientists, ask lots of questions, find out what it's like to travel in outer space. So Paul, help me now. We're going to see if we can see what it's like to maneuver this thing.
Joy, thanks so much for introducing the show, and I believe we've got a live studio audience over here, and we've got a couple people to introduce their classes. Go ahead, Devin.
I'm Devin Johnson with Inner City and Classmates.
And I'm Abel Cerna, and I'm here with my friends from the Pasadena Independent School District.
You guys go. Well, that's exciting. Are you glad to be here today? It sounds like you are. One more time. Let me know you're glad to be here. Come on. All right. Well, I tell you what, we've got a great show planned for you today, and I want to introduce a few of my friends that are here, the students that are going to be with me here in the Space Station module. Again, I'm Phil West. I'm an engineer here at NASA, and I'll be one of your hosts for the show, but we've got a lot more than just this space. Manny is from New York, right, Manny? Why don't you wave to the camera? He's pedaling a bicycle ergometer, and we're going to come back and perhaps talk about exercise in space later. We have Sarah over here from Wisconsin, but Sarah, hey, Sarah. Hey, wake up, Sarah. Sarah's been asleep for a while. It's kind of embarrassing. We're trying to do like the show here. Sarah, can you wake up? Oh, okay. Sarah's from Wisconsin. Big welcome for Sarah. And we had one other guy show up this morning. He's Nathan, but he didn't shower, so we forced him to take a shower. Hey, Nathan, can you say hello? Hey, Nathan. That's Nathan, everybody. Big round of applause for these guys up here today. We have got so much planned for you. We've got other locations around the Johnson Space Center and actually even around the United States that we'll be going to throughout the program. First, let me take you over to Building 9 at the Johnson Space Center, and that's where we have one of the coolest astronaut training facilities. You're going to check in with them later. That's Erica and company over there. Then we'll go over to the Mission Status Center here in Space Center Houston, which is a lot like Mission Control. Patricia Tribe will be over there with some of her friends. And we'll also be going out to the NBL, which is where we train astronauts underwater to mimic the weightless environment that they feel in space. So that's out at the Neutral Buoyancy Laboratory. Really cool test going on out there right now. And actually, we're going to see a test. Yeah, this is a live test. Astronauts are under the water in spacesuits. We'll talk about those spacesuits more during the program as well. So that's some of our astronauts training for spacewalks. And then perhaps the coolest place we'll go is Aquarius, which is an underwater habitat where today we have some people living underwater, some of our NASA colleagues, Bill Todd and Michael Lopez Alegria and Mike Gernhardt. Are you guys there?
Yeah, we're with you, Phil, in the Aquarius.
Hey, thanks for being here. Is that Mike and Mike? And Mike, can you guys hear me?
Yeah, Phil, Mike L.A. and Mike Gernhardt are inside, and Dave Williams and Bill Todd are outside. You may be able to see them through the porthole. I don't know if you have video, but we hear you loud and clear.
Yeah, we do. Thanks. Great to see you guys. L.A. and Mike Gernhardt, those are two of our astronauts. Dave Williams is an astronaut as well, and Bill Todd works here at the Johnson Space Center in our mission operations area. So we'll come back to you guys later. Thanks so much for being here as well. Now, I believe we're going to start off with Patricia over in the Mission Status Center. Is that right, Patricia? You ready to go?
You bet. We're over here in Mission Status Center, and we want to welcome everybody to Space Center Houston and to the coolest classroom that we have here on Earth. And this classroom is Space Center Houston and Johnson Space Center, and it's going to be your classroom for today. And so what we would like to encourage you to do is to phone in any questions that you have for our scientists and us here at Space Center Houston, or email us any questions you have. If that's a little easier, get on that technology and use that technology. And so we'll email those right on in. And I hear that we actually already have a question from somebody in New York. Caitlin. Caitlin, can you hear us?
Yes.
Hi, Caitlin. What's your question?
Can someone in a wheelchair or that is paralyzed can go in space?
Wow, that's a very good question. Who wants to take that question? Can we hop over to Building 9? And is our astronaut on board to take that question?
Well, I tell you what, absolutely, Patricia. You know, I was going to give a little bit of surprise to the students, but it's such a wonderful question that I'd like to go ahead and introduce now our special guest, Katie Coleman, our astronaut. And Katie, did you hear that question from our student?
I did. You know, right now it's a little bit limited who gets to go to space. It's folks that are already astronauts that are getting picked. And I would say that it's going to take a little while before, you know, there's some things that we don't know how to do. And so we don't know what we're going to be required to do. And so right now you have to be pretty fit, and there's a lot of medical testing that goes on. And so I would say it's going to be a little while before we can take folks that are handicapped to space, but I think that there's a future in it.
All right. Well, thank you for that question. Back to you, Patricia.
All right, thank you everyone over there in Building 9. And I would like to take this opportunity just to introduce one of our special guests here today. This is Dr. Jim Peters, and he is a scientist and an engineer who's been working on the International Space Station. And he's going to just talk to us for a minute about this model that we have here of the space station.
Thank you very much. What you see here to my right is actually a mock-up of the International Space Station. And although it's made of wood and plastic and cardboard, it's a pretty good replication of the three main components of the International Space Station. Now, as you take a look at this, the first most important component is actually the white PVC piping, and this is actually the pressurized modules, and this is where the astronauts live and work on a day-by-day basis. And if you take a look at the second most important part of the structure here is actually the truss segment here, and this is the backbone of the International Space Station. And the importance of the truss structure primarily is to contain these super large elements here that are actually the solar panels, and they are used to convert sunlight into electrical energy to power all the onboard avionics and flight control systems on the International Space Station. And for the most part, the space station is constructed of aluminum, about the same thing that aircraft and even your soda cans are made of. And here's some examples of some of the aluminum components. This happens to be a handrail that the astronauts use whenever they do spacewalks to grab onto and move along the space station during the assembly process. In addition to that, here's kind of a tool. Looks a little bit different than a Craftsman tool you might be familiar with, as a wrench. There's a good view of that, made of lightweight aluminum. And also, we also have titanium made as far as material as well. And on the inside, there's composite materials, but these are some of the things that are unique to Space Station. And one of the things you might find actually in the attic of your home is what we call insulation. And it's this pink fiberglass material, and the reason why it's in the bag is because it scratches when it gets on you. But one of the big differences with the International Space Station is actually use something called a MLI blanket, multi-layer insulation. And if I took this piece of material right here, which actually covers the entire volume of the space station, and cut it apart, you'd see that there's 18 different layers in here. Cool. And there's
very cool
polyester spacing in there to keep the heat from transferring from the outside of the space station to the inside of the space station, because the temperature extremes up there between plus 300 degrees to minus 300 degrees. Wow. And we want to maintain the internal pressurized volume at a nice, comfortable temperature of about 70 degrees.
Great. Well, thank you, Jim. We appreciate that. And I also have some special guests here with us today. And would these gentlemen like to introduce themselves?
Hello, my name is Jared from Schenectady, New York.
Great.
Aaron from Schenectady, New York.
And we have Joe, who is their teacher. And these folks have been working very hard on an activity that they are going to demonstrate for us. They are going to be docking modules that they have built using a robotic arm. So can you gentlemen jump in and start doing that? And Joe, could you just let us know what they're doing as they go through this?
Right now, they have two computers, and we have a robotic arm that has been lent to us by Pittsco, a company out in Pittsburgh, Kansas. And they are going to dock a module to the actual model of the International Space Station. To simulate this as closely as possible, when the astronauts go up and actually dock a module, they aren't able to look out the window of the space shuttle to see how the docking procedures are going. So what they're going to do is we have two remote cameras that are focused on the actual model, and Jared is working one of the remote cameras while Aaron is working the actual robotic arm. And they are working together as a team because without either one, we couldn't get this procedure to work.
And so they're simulating what the astronauts actually do up in space when they're trying to dock two things together. Is that correct?
Exactly.
Great.
Exactly.
Great. And we can see that the robotic arm is now about to grasp onto the module. And these two folks cannot see what they are doing, right?
Exactly. That's why the screen is set up so that the only thing they can look at is the monitor. And again, Jared is controlling either one of the cameras so that Aaron can see how the actual procedure is going.
And that sometimes happens too up on the space station. Sometimes the astronauts do not have a clear view of what it is that they are trying to dock or move around in the space station. And so when they're using the robotic arms, they use all of these computers as well to help them out. So this is a pretty real simulation of how things are done. And this is something you folks can do back in your own classroom. Grab a robotic arm, build a model, and practice being astronauts, docking these different models. We have a phone call coming in from Gary from New York. Gary, do you have a question for us?
Yes. Hello?
Hi there. Go ahead.
My question is there any dust or dust particles in space?
Is there any dust or dust particles in space? Jim, can we go to you for that one?
You bet. As a matter of fact, there's a lot of things in space besides just the dust particles that you alluded to, and that's one of the things that we're worried about at International Space Station because we want to try and avoid those things because we don't want to depressurize the module. And one of the ways that we keep track of that, we have people on the ground that actually can track up in space any type of small particle that might endanger the space station. So not only are we worried about the small particles, but also the micrometeoroid environment that's up there, and we do have capability to avoid any type of collision with some of those objects up there in space.
Very neat, very neat. We have another question from Shelby, who is in Texas. Shelby, can you hear us?
Yes, hold on just a second.
What's the question you have?
Can animals live in space?
Can animals live in space? That's a very good question. Would you like to go for that one too, Jim?
Definitely, absolutely. Just the same way as humans live in space, animals can live in space as well. Not only are animals going to live on the International Space Station, much the same way as they have done on the shuttle before, but once the space station is completed, those are some of the planned experiments. We want to see how the animals actually react in a weightless environment as well, because we're going to need animals if we want to go on further from the International Space Station, interplanetary exploration and so forth, or even colonize the moon. So absolutely, plants and animals alike can actually live in space.
Well, that's wonderful. We are now going to head over to Erica again, and she is in Building 9 over at the Johnson Space Center, and she is with Katie Coleman, one of the astronauts who's joining us on the show. Hi, Erica.
Well, welcome everybody, and welcome Katie. Katie Coleman is one of our astronauts who's joining us today and is going to share a lot of things about astronaut training and living and working aboard the International Space Station, because she's a veteran astronaut and has been on several missions, so we get to share that with you today. We want to tell everybody that we're actually live from one of the largest training facilities here at the Johnson Space Center. It's the SVMF, that stands for Space Vehicle Mock-Up Facility, right?
Well, all I know is that we're in the middle of a bunch of really big space station mock-ups, and they're actually really great places for us to learn how to live on the space station, how to make sure that we really know how to operate everything before we go.
Yeah, well, tell us a little bit about how you decided to become an astronaut.
Well, for me, it actually took seeing an astronaut that was Dr. Sally Ride. And when I never thought about being an astronaut, because when I was growing up, girls didn't get to do that stuff. And so when I met Dr. Sally Ride, she came and gave a talk at my school when I was in college. I thought, I want that job. But I will tell you right now, while we're live, and I know we have a lot of students out there, there is a secret to becoming an astronaut. And that secret is that everyone who is an astronaut is something else first. No one just starts off being just an astronaut. I am a chemist. That's what I did. So I actually spent a long time in school studying lots of different things, just like you're studying right now. So you are on the right track if you're thinking about joining us on the space station.
Excellent. Well, you know, it's interesting because this building houses the life-size models of where you guys train to live aboard the International Space Station. So everything is just about the same, and they're pretty big. As a matter of fact, I was wondering maybe you could show me inside of one of these.
All right.
Right, now this is one of the science laboratories, right?
That's correct.
Okay. And so basically the astronauts have a little bit of training that they do to kind of practice some of the things they'll be doing in space, maybe some of the science and things like that, right?
Exactly.
Okay, now the International Space Station, I already had a question. Who came up with that idea anyway?
Well, you know, I think that people have wanted to go to space for longer than we can all remember. And there's in fact a book books that were written back in the 1800s where they actually showed capsules. I mean, they thought of these long before we ever had capsules. Jules Verne wrote a book about that. But the first space station, in fact, was 1971, and that was the Salyut space station. And that was put up there by the Russians. It was up there for a few years. They had 2 crews that went up there. And then in 1973, the Americans put a space station up there. So this is not the first space station that we're visiting today.
So Salyut was the first, and then
Skylab.
Skylab was ours,
Was
right?
the second, that's
Excellent.
correct.
And came
Mir.
Oh, that's right.
And Mir was put up there in 1986 by the Russians, but has actually been used by many countries as training grounds, really, for the International Space Station.
Right, a lot of our astronauts stayed up there for long periods of time.
It's true. And some of the Russian cosmonauts and the American astronauts who have been on Mir are now space station crew members. And we're using what we learned in living on the Mir to live up in space on the International Space Station.
So even though it was a Russian space station, we really learned a lot from the Russian space program to be able to develop the International Space Program.
Absolutely. Right? And really, there's so much knowledge that the Russians have and all the other countries that have participated on Mir. There's just no sense in us trying to do it alone.
All right. Well, you know, the International Space Station is where we are today, so I think it's 16 countries total?
Absolutely. 16 different countries that make up the space station.
All right. Well, you know what, Katie? I hear that we have some email questions. Phil?
We do, Erica and Katie. Thanks so much for being on the show, Katie. Glad to see you. Hey, we got a question I think that would be great for you, Katie, and that is, even though you are an astronaut, do you still live a normal life? And of course, we know it's you, so there's no normal life about you, but what do you think?
Well, you know, my mother said that she's glad that I got a job in a place she thought I lived for a long time in outer space. I mean, I do have actually, you know, somewhat of a normal life. It's a pretty busy life, but I have a husband and I have a baby, and you know, so I think those things are pretty normal.
Yeah, absolutely.
And he just thinks that everybody's mom goes to space.
It's pretty neat. All right, Phil.
You know what, I want to, I've got one that's, I think, great for both LA and Mike Gernhardt over there at the Aquarius. This one is from Zach, and it says, how closely does the water environment compare to gravity in space, is the way he words it. Can you guys take that one? I don't know if they heard me or not. LA, can you hear me?
Yeah, Phil, we did hear you. It's a good question because there are a lot of parallels between being in microgravity and being underwater. As you know, we do a lot of training. I think you guys are going to see some training in a neutral buoyancy lab of us training underwater. And here at Aquarius, we spend a lot of hours outside, and the sensations are very similar in that we're obviously floating around. The difference is you can kick yourself with fins and propel yourself, whereas in space, obviously, you have to rely on holding on to handrails.
Now, Mike Gernhardt, I guess let me tell you again, both these guys have been out on spacewalks in the last year to help build the International Space Station. So let me toss it over to Mike Gernhardt, who's got a lot of undersea diving experience as well. Mike?
Yeah, Phil, to pick up on the question about some of the similarities and differences between working in space and working underwater, probably the biggest difference is that in space, the spacesuit is inflated. The pressure of the spacesuit is about the same as like a football. So when you work out in space, you have to work against the inflation pressure of the suit, and it makes it real tiring on your hands, your wrists, and forearms. Also, underwater, if you drop something, the water's pretty clear. You can always go pick it up. Whereas in space, if you drop something, it's going to float away and you're never going to get it. So we have to tether everything. So there's a lot more overhead in terms of working in space than there is underwater. And Phil, if I could just suggest, we've got a couple of aquanauts outside that'd be happy to take some questions, and they're in a better position even than we are to talk about the similarities and differences between space and water.
Hey, let's do that. Let me show, while Mike mentioned the tethers, I've got one of the Hubble Space Telescope power tools, the old one we used to use, and you can see that tether on it, and that's built into the tool so it can clip off to the astronaut's suit, and they can use it without dropping it. I do have a great question, and Dave Williams is the right person to answer it, I believe. Dave, if you can hear me, feel free to comment on the life underwater versus life in space, but if you could specifically comment on this question from Matthew in Mrs. Rushby's class. He asks, when your bones get weak, do they stay like that forever, or do they get better?
I'm going to repeat the question to Dave, Phil.
Okay.
Dave, why don't you swim away and maybe you can hear me a little bit better. The question is about loss of bone density, and if you lose bone density and bone strength in space, does that affect permanent or does it get better?
Whether or not that gets better. In fact, when we come back to Earth, the changes in muscle and bone strength reverse when we come back to Earth. Working down here beneath the surface of the ocean, of course, we get to maintain our bone strength and density because we are working in a gravitational environment.
Bill, were you able to hear that answer?
Yeah, we were. Thanks very much, Dave. Dave's a doctor and is well qualified to answer that question. I tell you what, LA and Mike and Dave and Bill down there, why don't you guys give us a tour of your facility? We're going to spend some time with you now in the program.
Okay. We'll come back inside with the camera. Let us know when you have the inside shot. And Ryan, if you can kind of pan around. Go this way. Yeah. Yeah. Are you able to see our video now, Phil?
Start on the wet board. Can you hold that camera?
Phil, are you able to see our video now?
We have a walk around, but no, just and you guys. Alright. I'll start out there and open that door and talk.
Can you be underwater?
Wow, they're getting situated down there underwater. And again, this is Michael Lopez Alegria and Mike Gernhardt with Dave Williams and Bill Todd down underwater near the Florida Keys, and they're going to give us a tour of Aquarius. And we're ready for you guys anytime. If not, we'll take a question.
Okay, Phil, can you hear us?
Yes, we can.
Okay. The video that you're seeing, I'll pick up and let Mike try to narrate, but we're looking toward the aft end or the stern of the Aquarius module, which is about the same size as the service module, about 43 feet. And Mike, why don't you carry this microphone and give him a tour?
Okay, Phil, I'm heading into what we call the entry lock, which is one of the 4 areas of the habitat here. And in the entry lock, like all of the locks, we have their own separate breathing gas supply in case... Stand by. Anyway, we have our own separate breathing gas supply. I don't know if you can see with the camera, but I'm about to open this door to what's called the wet porch. Let me know if you can see this. And out here is the wet porch, and that's actually where we put on our scuba gear with our wetsuits and our double tanks and so forth. And what we've got here is the shore calling at the same time here, so we're getting a little bit of congestion on the loops. But at any rate, this is the wet porch. This is where we dress in and go slap out of the habitat to work on the reef.
Now, Mike,
Mike, I'll turn it over to you.
Go ahead, Phil.
well, I was just going to say, I know Mike Gernhardt helped install the porch, if you will, on the International Space Station, a slightly different type of porch, but LA, you can probably describe that.
Well, as Mike said, that's the place where we enter and exit the Aquarius module. And what I'd like to do now is switch to our outside camera and show our 2 aquanauts out there, Dr. Dave Williams and Mr. Bill Todd. Dave and Bill, if you can sort of swim away from the camera so we can get a good view of how big the Aquarius module is. There you can see them, Phil, I hope.
Yeah, we can see them great. Great shot.
We're sitting in about 60 feet or so of water. The hatch depth at the habitat is about 45 feet. We've been down here for about 2 days now, and we've got about another 5 days to go. We're in what we call saturation, so that the gases that we've been breathing are saturated into our tissues, and that allows us to stay underwater for much, much longer than we normally could if we were doing dives from the surface. It's a great advantage for scientists because they can spend a lot more time studying coral and other water sample and other studies that they like to do down underwater, and we're actually collecting some of those data for the scientists during our mission.
Now, LA, that also means you can't surface in a hurry if you need to. That means that as well, doesn't it?
That's right. One of the real advantages of this facility is we're trying to use it as an analog to spaceflight for training long-duration crews because it's very similar in that it's a fairly comfortable environment here, but it is somewhat dangerous. If you have a problem, you can't just panic and surface because you'll have some problems with decompression sickness. So you're right in that it is kind of a different scenario. Normally when you're diving, if you get into trouble, you can always just pop up to the surface. In this case, the bottom is our haven, and we actually come back to the habitat where anything.
LA, you dropped out for just a moment, so we're going to take a question here from our live studio audience, and perhaps we can come back to you for that. Go ahead, you got a question?
How long can you stay underwater?
The question was, how long can you stay underwater? Guys, you get that?
That's a real good question. For this mission that we're on, we'll stay underwater for about a week, but there's no reason we can't stay under longer. And in commercial deep sea diving, people typically stay underwater a month to 2 months at a time. And usually there the limitation is not so much physiological as it is, you're ready just to come up and breathe the air and smell the breeze and see the sun and so forth. So there really is theoretically no limit to how long we could live underwater.
Now the other part to that question is we can only stay in the water for as long as we have air to breathe. However, we do have the ability to refill our tanks while we're outside, so we can continue to refill until we get so hungry that we need to come back in.
All right, we've got a question over with Patricia in the Mission Status Center.
Hi there, and we have a gentleman from New York who has a question. Go ahead.
How long will it take you to get back to the surface when you're done training?
That's another great question, and the advantage of saturation diving is that your decompression time takes the same once you're saturated, whether we stay down here another minute or another month. And at this depth, our decompression time will take 16 hours. And so, we're going to work for a week and we'll decompress for 16 hours. And that's a lot better than if we, say, worked for 2 hours down here and had to decompress for almost 3 hours. So the advantage is staying down here for a long period of time because you've got the same 16-hour decompression.
And Phil, just a technical comment. We're hearing a lot of audio from people in the different centers at the same time. I don't know if there's anything you can do about that.
Great question, and thanks, Mike. LA, we'll take a look and see if we can do something about that. And I think we're about ready to sign off with you guys anyway. Is that correct? Okay, tell you what, we're going to toss it back over to Erica and Katie in Building 9 at the Space Station Trainer. And at the same time, we'd like to say goodbye to the guys at Aquarius. Thank you so much for joining us, everybody, and have a great rest of your mission.
Okay, Dave, how about waving goodbye?
Thanks, Phil. See you guys.
Yeah, thanks, guys. Erica?
You know what a neat experience, Katie, to be under the water there in the Florida Keys. That was really cool to be able to ask the astronauts questions under the water.
Well, I'm pretty envious, actually. This is a really good way of getting ready for living on the space station. It's important for us to really have that feeling of you can't just surface anytime you want. You have to serve the problems yourself. And so that's a really valuable training, and it's nice to get to see that they're having such a great time.
Right. Well, we're well on our way to getting prepared for a fully completed International Space Station. It's going to take us a little bit of time, though, to put it together, and maybe we can take a look at how that's going to look on our screen right now. Explain to us what we're looking at.
Well, you see a lot of different colors of the different modules, and that shows how many different countries are making up the different modules. There's the power modules, most of those are yellow. that's the U.S. We've got the red modules are Russian, and we've got experiment modules. You see all the different pieces, but in just a minute we're going to see a video that shows you how they go together. Now, they don't go together as fast as they do in the video, but first you're going to see the very first module. There we go. We're starting to get assembled here. The first couple, it's already possible for folks to be living up there, which they are. But you see now we've got power, we've got these solar arrays that give us power, we've got cooling, more and more modules, more and more capability to do science experiments. And as you can see, that, I mean, the real station will not grow this fast, but this is not a small thing orbiting the planet. This is an amazing space station that will be the size of like 2 football fields. So compared to the space shuttle, I think this module right here is big. But when you've got all these linked together as a space station, it's going to be tremendous.
It's going to be huge. This huge research laboratory. And interestingly enough, it's going to be possibly on orbit maybe 15, even 20 years. So the students watching today could possibly graduate from school and come to work for the space program, and will still be doing important research on the station.
Absolutely. And who knows where we're going to go from here. The space station right now is the next step, but there's some pretty cool ones coming up. The moon, Mars, who knows?
Yeah. Let's take a look at some of the things that you guys are training for and some of the research that we're going to do on station.
Okay. Now this is actually a film of when the first module is up there, launched by the Russians, and now we bring up the second module in the cargo bay of the space shuttle, and Nancy Curry has picked this up. You're seeing her pick up the module with the robotic arm, so that little bitty wrist is picking up like a 40-ton module. I'm actually not sure how much it weighs, I just know it's big. So she picks it up, they attach it, and now they're opening the hatch, and we are officially entering the space station from the space shuttle. They've opened up that hatch, and they are going in. This is Sergei Krikalev and Bob Cabana. And now you're getting a little tour of going into what we call the node. That was the module that they just attached. A node is just like it sounds. It has a bunch of different doors going in different directions. And so these different directions are going to lead to different modules. Like here you see a sign going to the HAB, going to the FGB. I mean, we've started with a small place, and it's getting bigger and bigger. And one thing that I think is good to remember is just that you actually can do everything in 3 dimensions, including pick your CD. Now you're going to see some of the science experiments that we're doing up there, and we are growing cells. This is protein crystal growth. We can grow crystals much more perfectly in space than we can here on Earth. It allows us to design drugs to cure diseases. It's very exciting. This is actually a plant growth experiment from one of my missions. And we're seeing, what do plants want to do in microgravity? We need to know if we're going to go to Mars. It says speed limit 28,000 kilometers. That's how fast the space station is going. There's Susan Helms and Yuri practicing getting ready for spacewalks on the space station. And this is the same. This is training in the neutral buoyancy facility, getting ready for those spacewalks. And there's actual spacewalks in space.
Oh, look at the astronaut waving right there.
And that was actually someone waving to the folks inside the space station.
All right, and look there.
And now we've undocked. We visit the space station, bring up new parts, but eventually we have to go ahead and come back home as the space shuttle. But the space station stays up there, and there are folks living aboard there right now, 3 of them.
So very exciting times, and hopefully the students are getting interested enough to be able to come and work for NASA one day, get out of school, and come help support the International Space Station program. Well, Phil, it's back to you now.
We have some questions coming in, and the first is Stormy in New York.
How do you get picked to go into space?
How do you get picked to go into space? Well, tell you what, that's a really good question. I think Katie is ready to take that question, it sounds like. So let's throw that over to Katie Coleman. How do you get picked to go to space, Katie?
Hey, just repeat that question one more time for me.
Hey, how do you get picked to go to space?
How do you get ready to go to space?
No, picked. Like, how did you get selected?
How do you get picked? Well, if I knew, I'd already be on a different mission, but all I can tell you is that you've got to just do your job as well as you can all the time. All astronauts will actually go to space, so once you get picked to be an astronaut, then you know you're going to go to space. You're just not sure which mission, and so it's your job to be the best you can be. I'm always studying. Every single day, I will tell you that I am studying new things to make sure I can do my job well.
Jonathan from Wisconsin, I believe. You're on the line.
I was wondering how much air is available on the space station.
How much air there is on the space station? Is that what you said?
Yeah.
Well, that's a very good one. We've got to have air on the space station, don't we? We want to be able to breathe. I'm going to throw that over to Patricia and Jim Peters over there. Air in the space station.
Well, that is a great question. And Jim, do we have enough air to stay up there for a long time, or does this air have to keep being refueled or refinished?
Actually, we have two oxygen generators on board the International Space Station, and one is the primary means, another is a backup, and they actually use water as a way to, and run an electric current through the water actually produces hydrogen and the oxygen that the astronauts need to live. The backup system, if both of the oxygen generators should malfunction, we have oxygen tanks there in reserve as well, so we have more than enough, ample supply to sustain the astronauts for extended periods of time. And that's how we provide the oxygen.
That's great, thanks. All right, let's go back to Phil. We have some more questions.
There's one more comment I wanted to make on that. You know, the oxygen is very key. There's also nitrogen inside the space station because air is made up of nitrogen and oxygen, but the nitrogen doesn't get used up. It leaks out. Some of it leaks out, but it really doesn't need to be replenished nearly as much as the oxygen does. So that's something to think about in your chemistry classes in high school. I believe we have Tristan from New York on the phone. Tristan.
What is the hardest part of being an astronaut?
Oh, what's the hardest part of being an astronaut? Well, you know what? I'm going to try and respond to that briefly, even though I'm not an astronaut. I'm an engineer. But I believe Katie is getting ready for us over there to answer that question. Oh, we're good. We got Katie. So let's go to Katie in Building 9.
Well, Phil, the hardest part of being an astronaut is knowing that actually a lot of other people would like to be astronauts, and that makes me feel like it's my responsibility to do the best job that I can. And it's not always easy. I don't always do the best job, but it is my job to try. And so that's why I study every day. I'm always trying to learn more. I'm always trying to be better at what I need to do to be an astronaut. And so all the things that you study in school, I can assure you, you will use when you have my job.
Okay, we've got an email question here I want to throw out. This comes from Lindsay L. at Pinewood School, and she wants to know, why does water form a bubble in space? Well, let me say that one of the reasons why water forms a bubble in space is the same reason it sort of beads up on your car when you first wax your car, or if you see it beading up in a little ball on your countertop at home. That's because of surface tension. It wants to hold itself together into a ball. Now, what's interesting in the weightless environment of space is that when you remove the effect of gravity, then that ball just floats around inside the space station. And you've seen that on orbit yourself, haven't you, Katie?
You know, I have. And what you're talking about is really doing fluids experiments in space. Up in space, we get to see what fluids or liquids really want to do. Down here on Earth with gravity, well, water's going to be a puddle on the ground, and we don't know what it really wants to do. But in space, we have a chance to find out.
We've got a question from the live studio audience here in Space Center Houston. Let's go there.
Yeah, how do you get prepared to go into space?
How do you get prepared to go into space? Well, you know, in fact, Katie, I'm taking a class right now at night, and so I'm back into exams, and I've got to get ready for those exams, and it's kind of the same thing, isn't it? You got to study a lot.
You know, you really do. I am learning right now about the space station robotic arm. That's new for me. I know some about the space shuttle robotic arm, but now the big arm, as we call it, is brand new. It works differently, and I will actually go and spend a week learning about nothing but the robotic arm, and then it'll be my job to remember that stuff and to review it. So again, I'm always studying. Now that we're building the station, there's always new things to learn about, and that's my job.
So you're the perpetual student.
It's true.
Well, you know what? I tell you what, I told Erica this earlier. I blew it. I got some lunch, but I forgot to get breakfast this morning, and that is a bad start to the day. I think you've got an expert over there to help us understand how the astronauts eat well in space.
Absolutely, Phil. Thanks so much. As a matter of fact, we do have a food scientist with us today. This is Vicki Claris, and she works in the food laboratory here at the Johnson Space Center. And joining us also are two young astronauts, Ayla and Joe, who are from Schenectady High School in New York. Welcome and join us. Thanks for joining us today. You're welcome. Excellent, Vicki. So tell us a little bit about astronaut food. Is it different from what you and I eat every day?
Well, the foods themselves are not all that different, just the way that they're presented and the way that they're preserved. The foods that I'm going to show you today are the same foods that we take on board the shuttle, also aboard the International Space Station, and in fact our aquanauts down in Florida, whom you spoke to or heard from earlier, are also consuming the same U.S. provided space food during their stay down there. The only difference in the International Space Station is they also have Russian food items as well available to them. Some of the types of food that we send, this is thermostabilized food. It's just like your canned food at home. except that it's in this flexible pouch rather than a traditional can because it's lighter in weight and easier for us to stow. We also have a lot of different food and beverage items that require the crew members to add water prior to consumption. What the crew members do with these rehydratable foods is they inject water from the galley, from a needle, into the package, and then once the food is rehydrated, they can cut the package open with a pair of scissors and eat out of the package with a fork or a spoon.
Now, what is that, by the way?
This is actually some freeze-dried scrambled eggs. It's called Mexican scrambled eggs because it has a little bit of dried peppers and onions in there to give it a little bit of spice, which a lot of our crew members really say they like when they're on orbit. Spicy foods.
I have one question. What's this other language on this package?
Well, actually, it is in Cyrillic, in Russian as well, so that our Russian crew members on station, to make it a little bit easier for them to read the instructions and the name of the product.
These are made specifically for the astronauts, right?
Yes. Some of the items are commercially available items. For instance, this is a Del Monte product, but we repackage it in a package to make it more convenient and easier for the crew members to use on orbit, and also to reduce the amount of trash rather than having it in a big, large package.
Right. And what else do they use the barcodes for?
The barcodes, we have two purposes for the barcodes. One is for inventory on the ground here when we're stowing the food, to keep track of what we've stowed for the astronauts. And then also on orbit, sometimes for medical experiments, our crew members have to record everything that they eat. And so the easiest way for them to do that is to just scan the package with a barcode reader, and that way they can record automatically the things that they've consumed.
Now we have some pictures of a couple of trays that the astronauts have used to be able to hold their food on.
Yes, yeah, we have some video, and this shows, this was the original space station, our shuttle tray that we had early on in the shuttle program. We've changed the packaging a little bit, so the tray has changed a bit over the years. Our crew members get to choose what they want to take with them. We have a rather extensive food list. About 150 or so items that the crew members can choose from in planning their menus. And
speaking of that, that's interesting. Don't we have a little bit of a video where the astronauts
yes, we
are doing
do.
kind of a taste test?
I think we do have some video on the selection.
There we go. Tell us a little bit about what they're doing. They're actually showing, this is on the ground, kind of showing what they pick out, right?
Mm-hmm.
And this is astronaut Shannon Lucid. And she spent a lot of time aboard Mir. Now, was she able to bring American food with her?
Yes, she was able to bring some American food items with her, but not quite as many as the 50% that we have now on orbit with our expedition crew members.
Right. And so the video that you saw there was actually the astronauts taste testing. So they
in our lab.
Right.
They come to our lab, they get to try the different food items, and then they choose from that list the ones that they want to take with them.
So if Ayla and Joe were on a crew, they actually could have individual menus and possibly eat something different for breakfast, lunch, and dinner.
Definitely.
Okay, I know about some of the nutritious foods, but what about the goodies?
Well, there's goodies too, or we call them natural form foods, better known as junk food though. Cookies, candies, crackers, and nuts. Those kind of things are available for our crew members as well, because astronauts are just like any other group of people. They like to have their comfort foods and their goodie foods as well.
Well, you know what? With some of our friends over there at Space Center Houston, Phil would like to show us some things about preparing food.
Erica, yeah, I know you've got the latest trays and things over there with Vicki. I just wanted to show you some of the ways we were considering packaging food in the space station was kind of a pulled down thing like this. Now I'm here with Arnold and Tara, and they've already got a piece of food they've selected out. Put it in the tray here if you would, guys. In this case we used Velcro. I know you used some different things with the tray that we finally wound up with for Space Station. But Arnold, why don't you show us what's unique about this as well? We've got a magnet on there to hold the spoon, so the spoon is not going to go anywhere floating around in zero gravity, right? In the weightlessness of space. So that's something. I think you guys have got a tray over there as well, don't you?
Oh, okay.
Erica, do you have a tray over there as well?
Oh, yeah, absolutely. We don't have a tray, but we have something a little bit cooler, and that is two taste testers here. And they are brave enough to taste some of the space food. So Ayla and Joe are going to try out what today?
Well, we have some freeze-dried strawberries for them to try, and we also have a orange drink for them to try as well.
All right. I'm just curious to find out, so let's see if Joe can get a taste real quick and he can tell us what he thinks. What do you guys think about this?
It's good.
It tastes really
Not too
good.
bad.
It's a little bit chewy, but the taste is still well preserved.
Sounds pretty good. So you guys can possibly take a drink and find out some things as far as how much the drink might be similar to what you drink here on Earth. And by the way, what are those clamps for?
Well, actually, the straw has a clamp on it so that in between sips, the crew members can close the clamp. And this will prevent the fluid from flowing out of the package and into the cabin in microgravity.
That's right.
What are these Velcros for?
Well, the Velcoins that we put on all the packages help the crew members to attach this, because there's Velcro really a lot of places on the mid-deck of the shuttle. So they can attach the packages, they can take a drink with them somewhere, and make it easy for them to restrain it while they're doing other things.
All right. Well, I know for a fact that Patricia's standing by with some questions. Hi, Patricia.
Hi there. That was really interesting. It's making me kind of hungry, actually. I believe we have a question from Lennon from New York. Lennon, what's your question?
What would happen if you ran out of fuel in space?
What would happen if you ran out of fuel in space? Wow.
That's not a good situation. We try and plan to prevent that from occurring. However, if we did run out of fuel in space, obviously we'd have to make the trip back to Earth and so forth. But like I said, we try and plan accordingly to make sure we have enough propellant for the propulsion system, both on the International Space Station and shuttle, to ensure we don't run into that problem. But if we did, we're going to have to come back home.
Great. All right, and we have another question from Joseph in New York. Hi, Joseph. What's your question?
Hello. I was wondering how many years it took of training to become an astronaut.
How many years of training did it take to become an astronaut? And I believe we can go right over to Katie, and she can answer that question for us. Katie.
Absolutely.
Well, I'm going to have to count on both hands and both feet. Let's see, I graduated from high school in 1979, and I became an astronaut in 1992. So by my math, that would be, 12 years, 13 years after high school. You know, I know it sounds like a long time, but really you're just learning different things every single day, just like you are in school. Every day is different, every grade is different. And I'll just tell you that the things that you're learning, all this math, all this science, writing, all these things, I use all those things every single day. Learning to talk to each other, learning to work in groups, all those things I use every day. So it may sound like a lot of years, but it goes by pretty fast.
Great, thanks, Katie. And we have a question from George from New York. Hi, George. What can we answer for you today?
Hello.
Hi.
I wanted to know how, like, when you come back from your destination, how do you land?
When you come back from your destination, so if you're up on Space Station and you come back, how do you land? That's pretty neat, too, because the shuttle, when it takes off, is like a rocket, but when it comes back down to Earth, it's like a glider. Isn't that right?
That's absolutely. And the shuttle, like you said, it is a rocket, and it's designed to launch from Earth. There's gravitational attraction in order to get up and dock with the International Space return. It's basically a glider for all practical purposes, and can land in Florida at Kennedy Space Center, or actually out in California on a regular runway, the same as a 747 would land. It just happens to be a little bit longer runway and a little bit wider, because the space shuttle is landing in a lot higher airspeeds, and it's a lot bigger vehicle as well. But it's just the same as a glider landing on an airstrip.
No. And we have another question from Joe from New York. Josu, I'm sorry. Josu from New York. Hi there. Hi, Josu. Can you go ahead? Well, we don't seem to be getting through to Josu right now, but I want to just add one thing to that shuttle question. When they come in and they're landing as a glider, they only have one chance to land. Isn't that correct?
That's absolutely right. You have one shot to do it, and that's why there's so much training involved in preparing the astronauts for each of the upcoming missions, because they need to get it right, and they need to get it right the first time, because that's the only shot they have.
Great. Okay, and I think we're going to pop back over to Phil. Hi, Phil.
Hey, Patricia. I'm so glad to hear all that cool information. We are over here, and we're going to talk about space clothes.
Phil, I think
Nathan, I'm trying to introduce the next section of the show, man. I gotta go on here, okay?
But Phil.
What?
You're forgetting something.
What?
Look at what you're wearing. It's your underwear.
I'm not in my underwear, Nathan.
Look down, Phil.
Ah! I'm in my underwear!
Yes, you are, Phil.
That's not good at all.
No, it's not, Phil.
You ever have a bad dream about showing up at school in your underwear? It's my worst nightmare. Ah! This is not actually my underwear, and the show must go on. It's astronaut underwear. So let's just make use of the situation and talk about underwear, shall we? I think so. This is the underwear you wear underneath a spacesuit. So let's talk about space clothing. Now, it can get very hot or very cold outside your spacesuit. In fact, it can get so hot outside your spacesuit that, and your own body heat is so trapped inside that spacesuit that your own body heat has nowhere to go. So you have to pump cold water all over your body to keep you cool. And that's what is done with this fancy underwear. You pump water in and out of these connectors, and that pumps all of your body and keeps you nice and cool. All right, so now let's talk about a spacesuit. Well, a spacesuit is just a big balloon shaped like a person, right? This is an elbow and a glove of a spacesuit, and here's the same thing on the actual spacesuit. So let's have Sarah squeeze this elbow and show you what it's like. See how soft that is? She can squeeze it very easily, all right? Now, she's going to come over here and pump this one up and watch the gauge very carefully. She's going to put air inside of this part of the spacesuit, the elbow and the glove, and you'll see it start to fill out. Well, that's what a spacesuit is really like. It's not just a heavy set of clothing. It is a balloon, and she's going to pressurize it here. Now, once you start feeling that for him there, Nathan and Manny, you can probably squeeze in there too, and you can see on camera how stiff it's become. Pretty stiff, isn't it, Manny?
Yes, it is.
It's a lot more so than when it started. So, see that? Very tough. Well, that's what a spacesuit is like when it's actually pressurized. Okay, well, Sarah continues to pump that up. Let me show you the pants here. I think you guys have got that pretty well set, right? All right, now these are the world's heaviest pants. Why don't you lift that up? Yep. Are they heavy? Is that the heaviest set of pants you've ever lifted in your life?
These are pretty heavy, Phil.
Pretty darn heavy pants. Let's look at the layers in there. I said a spacesuit is just a big balloon, right? Shaped like a person. Well, that first layer is the yellow layer called the bladder. And that's what the balloon is. It holds all the gas in the suit. Okay, when you inflate it, that's what you're inflating. And it's all sealed up here with a urethane coating. And that's like, it's nylon. It's like your backpack might be made out of. Or polyester here is used right above that. That's also a good backpack material. This might be a camping tent or something. Then right above that is a lot of insulation.
Is that aluminum?
It is very much aluminum. It's actually aluminized mylar. So we take mylar and we aluminize it or put aluminum on it. And that is the insulator, very much like the insulation that Jim showed you over there with Patricia earlier. And a real tough layer on the outside. Why don't you guys feel that? That's got Teflon coating on it. You know what Teflon is used in?
Like on pans and pots?
Yeah, pots and pans, exactly. Same kind of stuff. And that's very slick so that you don't get a cut in your spacesuit. You don't want to get a cut out here or a tear here because you don't want to get a hole back here in your bladder. It's a good plan to avoid holes in your bladder, okay? Yep. Keep a note of that. All right, now put the pants down if you would, and I think we can take a look at the rest of this. Of course, we got a chest pack and a backpack and a hard shirt. Sarah, why don't you reach under there and you can feel pretty hard, isn't it? All right, that's a fiberglass shirt we build the rest of the spacesuit off. Of course, we got a helmet. Now, it's very bright in space, you have to remember. Out here, when it's bright, what do? When it's bright outside?
You wear sunglasses.
Right, or if you're driving the car around, you might pull a shield down, right? Well, here the astronauts have a fancy pair of sunglasses, right? And then they can also actually pull opaque visors down to get the real bright sunlight out as well. You've got a chest pack and a computer, and you guys know what's in the backpack? Any suggestions?
Oxygen.
Yeah? What else?
Maybe some pumps to keep the pressure in.
Right, pumps. Sarah?
Water.
Yeah, water, very key. You gotta have water both to keep the astronaut cool in this suit, but also to drink, right? We've got a drink bag, and this sits down inside the spacesuit. I'll show you. It goes right there, and you can drink water. Of course, it'll be full of water. Don't ever go outside without a full thing of water. That'd be bad, because you're out there for a long time. You know how long a spacewalk can last? Do you know, Manny?
6 to 8 hours?
Yeah, about 6 to 8 hours. We plan it for about 6.5. Good answer. But sometimes they take a little bit longer, and so we have to be ready for that. And eventually you have to come back in, right? Now, one thing I want to point out, look at the lettering on the front of the spacesuit here. You guys see that? Now, why would that be backwards? You know something, Sarah, do you know why it's backwards?
So that you can look into a mirror.
Exactly. You look in a mirror, your eyes are up here in your head, right? That's kind of key. You look down, you look at a mirror on your wrist, and you look back and you see it forward, just like the word ambulance shows up backwards. Now, you
the words out of my mouth.
You see patches up here on the front of the suit. You guys have a patch on your suit as well. Why don't you tell us about that, Nathan?
Well, this patch, every mission that NASA has its own patch.
Right.
So this patch actually was designed from a kid in a middle school that I used to go to for this mission in particular. And then he designed it. It was actually a contest in the middle school. And then he designed it. He won. And then they drew it up, made it computerized, and then gave everyone that's on this trip a patch of the same sort.
Awesome. So you got your own self-design, the home design patches. That's great. I think on the monitor we're going to see some patches from recent missions, We've got patches, and what we do here at NASA is we put the astronaut's name. You can see this, in this case, this is one of the missions, STS-96, which was a mission to the space station, and the crew's name's below it. United States Microgravity Laboratory, easy for me to say, is on there with the crew that flew with that. Their names are around the perimeter of the patch. And then we've got some other patches as well from recent missions. And of course, the design tells something about the mission as well. There's your patch that you just described there, Nathan. Now, one thing I want to tell you before you guys ever go out on a spacewalk, have you ever gone a long time without scratching your nose? Like, I want to challenge you. It's a necessity to scratch your nose, isn't it? You guys out there, you scratch your nose a lot, don't you? It's kind of important to scratch your nose. Well, try and go the rest of the show without scratching your nose. I bet you can't do it. If you're in a spacewalk for 6 to 8 hours, you got to be able to scratch your nose, and this is my personal little trick. Okay, remember the helmet's on top, and you can't stick your hands through the helmet, right? That'd be a leak, and that'd be bad. So you get the microphone here, and you ride this up on the inside of the helmet, and this is what happens. Watch this. Oh, yeah. Right there. That's it. Oh, that feels good. Only problem is it only works on my left nostril, so I kind of have to mentally transfer any itch to my left nostril. I believe we have a question from Building 9.
Hi, Phil. As a matter of fact, that was quite interesting. I think I'm going to have to remember that little trick.
Me too.
Ayla, our young astronaut, has a question for you.
How much do you think the spacesuit actually weighs?
Okay. How much does the spacesuit actually weigh? Well, that is a great one. It's actually nearly 300 pounds, about 280. Now, it depends on who it's sized for. We would have a different size spacesuit for Katie than we would for like Michael L.A., who you spoke to earlier from Aquarius, because they're different size people. So Mike's would be a little bit heavier because it's a little bit larger, but basically it's going to be in the 280-pound range all the time. Now, of course, that doesn't mean it weighs that much in space, but it still has mass, doesn't it, right? So it's still going to want to keep going in the same direction when you go down the trail like this. If you ever pushed a loaded shopping cart down the aisle and not been able to turn it, it's the same kind of deal in a spacesuit. You want to be able to stop, so you got to go slowly and methodically. And I think Patricia has got some information for us on how astronauts train in space and what happens to their bodies in space.
You bet. Thanks, Phil. And I personally think that underwear is pretty darn neat. So thanks for showing us all that, Phil. Microgravity, it's kind of a tricky kind of thing to talk about, but I have a question for all you scientists out there and for our two young scientists here, Aaron and Jared. Is there gravity on Earth?
Yes.
Can we turn gravity off on Earth?
No.
No, he's right. There is no such thing as a zero gravity room here on Earth. We've got gravity and it's with us forever, and we're stuck with it, I guess you could say. All right, another question for all you folks out there. Is there gravity in space? That's a little tougher. What do you think?
Yes, I think there's 88% gravity in space.
You know stuff, don't you? You're smart. You're right. 88, where the space station is above orbit, there is still a lot of gravity. About 88% of Earth's gravity is still up there on the space station. So if that's the case, then how come we have astronauts floating around weightless? That doesn't seem to make sense, does it? Actually, the astronauts are floating around, there's no up or down, and they're traveling very, very fast. They are traveling 17,500 miles an hour. And when they're traveling at that speed, then the astronauts, the space station, and everything inside of it is in free fall. And that's how they become weightless, is because they're in free fall, not because they don't have any gravity. Now, there's two ways for astronauts to train to try and figure out how to maneuver around in this weightless environment. One way is in the neutral buoyancy lab. And we have some students here who are going to do an experiment with us. And we also have some live shots from the MBL. And you can see them underwater right now. And you can see some weights on their legs, right around near their calf. And those weights are being used to help make the astronauts neutrally buoyant. And by that, it means the astronauts don't float up or they don't sink down to the bottom. And that's that's how we can simulate a weightless environment down in the NBL.
Well, we have
All right?
about 20 minutes
Now
left.
we have some students who are going to try and simulate this neutral buoyancy effect. And you guys can try this at home, maybe in the bathtub, or try it at school if you want to do a science experiment. We have some water that's just a different color. It's red. And we have a big bucket of water. And Aaron and Jared are going to make this bag of water, I guess, neutrally buoyant. Go for it. How are you going to do this?
By adding weights.
Weights? Okay, let's go at it. Now, as these folks are doing this here, we also have our students over on the Living in Space show stage doing the same experiment. So in a little bit, we could probably check in with them. Oh, there they are. They're trying it over there, too. And Phil's holding a real astronaut toy as opposed to a bag of water. What have you got there, Phil?
Well, I do have a toy astronaut here, and the bad thing is he doesn't have a helmet, so that's really not going to go too well underwater, is it? But the astronaut, just like the astronauts in the pool, would initially float, right? But we hang weights off of them so they neither float nor sink, and that makes them neutrally buoyant, and that's exactly what you guys are doing in your experiment here, and Manny and Sarah are trying out as well. You guys doing that okay? Is it working out for you? It looks like Sarah is pretty close. Looks like this one's still a little bit heavy. Maybe if you move the penny off of that one, that might work. Patricia?
All right, thanks, Phil. And we have our little scientists here still working away on getting this. They had it floating, and then they had it sinking, and now they've added one more paper clip, and it's still coming up a little bit. Why do you think it's floating up to the top?
Because of the air inside.
Because of the air inside. So if we had more air inside, would that help, or do we need less air?
Less air.
Less air, okay. Oh, look at that. That's pretty close. Pretty close. So you can see it's pretty tough to get something neutrally buoyant. When the astronauts are getting suited up for their underwater activity in the NBL, it takes a while for them to get weighted out so that they're neutrally buoyant. The other way that we can train for the weightless environment up on the space station is on the KC-135. This is a way cool airplane. It goes really fast, and it does great big huge parabolas up in the sky. And so you can see on your screen the shape of the parabola and what the airplane does. Imagine being on a roller coaster, and that's sort of what you're feeling when you're up on this airplane. You go up and you're getting pulled on really hard, you feel really heavy, and then all of a sudden as you come over the top in that number 2 section there, you become weightless. You float up, and scientists and astronauts do all kinds of experiments on the plane, and they only have about 22 seconds to do that experiment. Then you fall back down, and then you feel really heavy again, and you come back up again. Now, Phil, I have been on this KC-135, and I had a great time when I was doing my parabolas. I got to float up and turn upside down and do some experiments with some students. I know you've had some experiences up there as well. Tell me what you've been through. And is the name Vomit Comet really true?
Yeah, they call it the Vomit Comet, don't they? And boy, I'm glad they do. It's very apropos, as they say. I've probably flown 800, maybe 1,000 of those parabolas, some in spacesuits, some out of spacesuits. And I think we've got a clip that shows you me trying to turn a bolt on the Vomit Comet. In your house, everything works out fine because gravity holds your feet to the floor. When an astronaut goes to turn a bolt on space station or any spacecraft, the bolt's not going to go anywhere. They're just going to spin around the bolt. Woo! Which we found to be sort of fun, but not very productive. So the astronauts got to find some way to hold themselves back to the spacecraft, or they'll just float around. Think of this as my spacesuit. I can do light tasks by holding on with one hand, or heavy work with clipping into a foot restraint, or medium tasks by clicking into a device like that, hooking up to the spacecraft and rigidizing it. And that'll hold me in place while I go off and do some medium load tasks. That's my little test on the KC-135, and boy, I learned that day that why it's called the Vomit Comet. There's nothing worse than riding a big roller coaster and then spinning around like this, so that's the deal.
Well, thanks, Phil. And we are back here in Mission Status Center, and we're going to do a quick update with our students who have been working on docking again, and they've got another module here. Jim, do you want to talk about what they're doing here?
Certainly. So thus far, they've done pretty well on the construction of the International Space Station. As you can see, they've added another node module and another international partner module behind this that you can see, and they're actually going to add another one here to the node. And as you can see, they're nearing completion of the activity of assembling the International Space Station, which in reality is going to take another 3 to 4 years to complete the 46 missions needed to put the space station all together and fully operational.
We have a question from Natasha in New York. Natasha, hi there. What's your question?
Hello?
Hi.
Do you know how long it would take a person to fly from Earth to the moon?
Do we know how long it would take a person to fly from the Earth to the moon? Do you have a guess?
No.
No guess. Jim, how about you? Do you have a guess?
Yeah, nominally speaking, the moon is about 250,000 miles from the Earth. And at the rate of aircraft travel or spacecraft travel that we have nowadays, it would take us about 2.5 to 3 days to go from the Earth to the moon, covering that amount of distance.
Wow. So quite a ways.
Absolutely.
But, okay. We have another question from Sam from Wisconsin. Hi, Sam. Hi there. What's your question?
What makes gravity, and why is there less gravity on space than on Earth?
What makes gravity, and why is there less gravity in space than there is on Earth? That is a great question, Sam. Wow. Are you going to be a scientist? That's pretty cool. Jim?
Actually, believe it or not, scientists really do not understand the full nature of gravity or its source, but what we do know are some of the characteristics about it, and some of the characteristics have been explained by some of the famous scientists like Kepler, for instance. And what Kepler says is that the further you're away from a mass such as the Earth, the less gravitational pull you have associated with that, the Earth in itself. And the moon also has a gravitational pull as well, and this is what's responsible for our tides. And these are one of the things that we want to study up on the International Space Station, is the interaction of the two planets, the Earth and the moon, and the gravity associated with each of those.
Great. Well, thank you very much. And I believe we are going over to Erica. And Erica's over in Building 9. Hi, Erica.
Hi, Patricia and Jim and everybody over there at Space Center Houston. I'm standing here with Shannon Gaspard, and her job is to get the astronauts physically ready to endure microgravity in space. So Shannon, tell us a little bit about how you work with the astronauts.
Well, just like we would work with them on Earth, is that we have to exercise them before flight, in flight, and when they come back. Being on the International Space Station for about 4 to 6 months is like being in bed and not moving hardly any muscles for that time. So what we do is we have some equipment in space that we use to help them keep in shape so that they have a body literally to come back to when they come back on Earth orbit. And what we have here is Jim Voss on the treadmill that we have on the International Space Station. You see that he has to harness into that treadmill. With no gravity, there's nothing to hold him onto the treadmill to keep him running on the treadmill. So he has to use a harness to get onto that treadmill. And he's getting ready and geared up to run on that so we can keep his cardiovascular fitness or heart muscle fitness in shape while he is on the International Space Station. And there you see he's running. The next segment, we have a cycle ergometer that we also use for cardiovascular fitness. And here's Susan Helms using the arm ergometry part of it so that she can keep her upper body in shape while she's on the space station. And there is her using it as a bicycle so she can keep her lower body in shape, and also we use that for the cardiovascular fitness. And there we have Bill Shepard, who is on the first increment, using our resistance exercise device. This is the device we use the most for keeping the muscles really strong and keeping them from deteriorating while they're on the space station. You see he's doing a squat while he's on the space station. And that's how we keep his lower body strong and fit and the muscles working and built up while he's on the station.
Well, I know for a fact that Patricia's standing by with an email for you.
Okay.
Email question.
Thanks, Erica. Hi, Shannon. We have an email from Nick here in Texas, and he has asked a cool question. Has it been determined how much gravity gravity is needed to prevent bone loss?
Absolutely.
And how much gravity
Yeah.
do we
And
need to prevent bone loss? Sorry about that.
How much gravity we need to prevent bone loss? Well, that's... no, we haven't actually determined that. One gravity is the best for keeping bone intact, but in zero gravity, yes, we do have some bone loss.
Right. Well, it's interesting. Okay, it's interesting about how the astronauts train. Now, do you do any work with the astronauts once they come back from being in space?
Yes, we do. We have rehabilitation. No matter what we do in space, there is going to be some muscle loss and some bone loss while they're in space. So we do have to do some rehabilitation while when they come back, and that usually involves a lot of stretching. I don't know if we have any shots of that, but we usually have some stretching and some water activity when they first come back, and then we build them into more resistance activity when they get back.
All right. Very interesting. All right, well, Phil, you have any questions over there?
Actually, we do have one that would fit in well over there, which is the kind of on the lines of what you were just saying. This is from Francesco. How do you know if you're getting enough exercise in a day? In other words, how do you measure that?
Okay. So how do you know if you're getting enough exercise in the day? And that comes from Francesco.
Oh, well, we actually do testing on them before they go into space to find out kind of where their bone density is at and where their muscle girth or their their muscle building is at before they go up. And then while they're in space, we do tests to make sure that that hasn't deteriorated too much. And if so, then we do some modifications for their exercise in flight.
All right. Well, thank you very much, Shannon. And something interesting that the astronauts like to do when they're in space is take a look at how beautiful the Earth is. So, Phil, I think you have some information on that.
We do, Erica. Thanks for that great information on exercise. I'm here with Kim Willis and Lucian Junction. Can you guys just wave here? Lucian is with our robotics group here at the Johnson Space Center, and Kim is with what we call Earth observation. So
that's right.
People understand the word observation probably and the word Earth, but when you put them together, what does it mean?
Well, our experiment on station, we think we have one of the best, by the way, is called Crew Earth Observation. So in NASA lingo, of course, that's CEO. And what we do is we monitor and analyze the Earth environment and its effect on the population. So how we do this is we have astronauts at the window, and they have cameras, digital and 70mm cameras, and they take images and photographs. And when we get these back on Earth, what we do is we put them in a database. Now, the really cool part about this is not only can Earth scientists from all over the world get this, but students like yourselves can get this as well. And if I might, I'd like to give them our website.
Yeah, please do.
Okay, that website where you can access these images is eol.jsc.nasa.gov.
So we've got some of those images we're going to put up on the screen and have you describe them to if you would.
Okay.
And I think this is great because astronauts can actually look to the most interesting spot, really. They're not just a satellite that's just taking a picture of a specific spot. They can say, hey, look over there, there's a volcano erupting.
Right, and this first image is a perfect example. It's from the first crew that went to the space station. It's a volcano called Popocatépetl, and it's around Mexico City, which is about in central Mexico. And it's a city of over 16 million people. So they happened to catch this ash and steam plume coming down from the volcano on this particular day.
That's really amazing.
This next picture is really great for students if they saw any of the Mummy Returns kinds of movies, because dead center, though, those three little dots that you see are pyramids. On the right, that's all the vegetation and things. The dark green, the dark colors are from vegetation from the Nile River. And on the left, that's where all the sand is. And like I said, right dead center are the three pyramids of Giza in Egypt.
It's amazing how the contrast. Now, the far left is actually just a black stripe, but on the far right was that really dark material, and that's just land for the most part. There's a river running through it, but there's land. It's just irrigated land.
That's right.
Versus the desert, right?
That's right.
Phenomenal difference there. Did I hear we've got a phone call? Brian from New Jersey, you're on the air.
I wanted to know if any astronaut has ever gone to the sun.
Has any astronaut ever gone to the sun? I'll take that one, and the answer is no. It's very, very hot as you get closer to the sun. In fact, the planets that are closer to the sun are much warmer in temperature than we are here at Earth. In fact, one of the reasons we can live on Earth is because of its distance from the sun. As you get closer, it's kind of like this bright light on my head. It's getting pretty warm as I get closer to it. Now, we do have some satellites that are going out continually taking pictures of the sun, and a satellite, which is sort of a robot of sorts, which we're going to talk to Lucian about, will take pictures of the sun for us and explore the sun. Justin from New York, you're on the air.
I would like to, my question is, how does weather affect takeoff, and what conditions would you need for takeoff?
How does weather affect takeoff, and what conditions would you need for takeoff? Do we still have Katie around? Katie, are you there? Could you hear that?
Yeah, I heard the question. Well, for the space shuttle, we actually need pretty good weather for takeoff, and that's because we like to preserve the ability to come back and land if we take off and things aren't good, things aren't working as well as we'd like them to be before we go to space. We'd like to be able to turn around and land, and we would do that 20 minutes later. And if the weather isn't very good, we wouldn't be able to see the runway, or if the winds were too strong. So for the space shuttle, we actually need some pretty good weather to take off. And we also need good weather at our abort sites overseas in Africa in case we decide to go there if we've got some problems. But so far, that stuff has never happened.
So if you're interested in weather and you want to work for NASA, we definitely have people that work for us and learn about weather in space. I think we have another question. Alicia from Wisconsin. Are you there, Alicia?
When you're going up into space, about how high do you get before there's no gravity?
Wow, okay. When you go into space, how high do you get before there's no gravity? Well, let me say one thing, and I think I'll toss it back over to Katie as well on that. We really don't get to a point where there's no gravity, at least where the space station flies. Gravity is always pulling on things out there. It's just that the space station overcomes that pull of gravity because it's traveling so fast as it falls around the Earth continuously. Katie, would you like to add to that?
Well, I'll just tell you the first chance that I feel no gravity is when we take off. We run our engines on the space shuttle for 8.5 minutes. That's how much engine thrust it takes us to get to space. And when we do that, after 8.5 minutes, when those engines cut off, boom, all of a sudden it's like this. And all of a sudden I'm weightless and my checklist is floating and everything that's not tied down is floating. If I take my helmet off, it just floats up and you know that you're in space.
I think we have time for one more phone call. Jacob from New York.
Yeah.
Hi, Jacob.
Where do you guys use the bathroom in space?
How do you go to the bathroom in space? Katie, I'm going to give you that one as well. And I'll tell you what, why don't I let you talk about the inside the space station, and then you can send it back over here. I can show them how they do that in a spacesuit.
Okay, well, going to the bathroom in space is actually really, really easy. Now, I don't want you to try this at home, but basically we have almost a vacuum cleaner, okay? I mean, in space, we need a way to either push things or pull things to make them move somewhere because they're weightless. And so we actually have a vacuum cleaner, and it's not like a vacuum cleaner like this. It's a really gentle sort of suction. And so for peeing, guys just pee just like they would here on the ground, and for women, they just put it right up against them, and they can pee, and everything goes in the right place. And going to the bathroom for everything else is just about the same. We just use that gentle suction, and it all works, and I'll tell you, it's a lot easier than like when you're out in the woods and things like that.
Great description, Katie. We've got sort of a mock-up of that toilet over here. And to complete the answer to the question, in the spacesuit, if you're out there for a long time, you may have to go as well. It's pretty technical. It's a diaper. And I've had the wonderful opportunity of testing those so they work properly when the astronauts get to use them. Of course, we change them out. They get new ones. Lucian Junkin is here, and he is a robotics engineer. He's going to tell us all about robotics on the space station and how we plan to use those to help build it and continue work to explore other things. Right, Lucian?
Yes. Hello, Phil. Hello, everyone. Thanks for inviting me to your classroom. We use robotics on Space Station to help Katie and the other astronauts out. And as you see on the screen right now, these are the new robots that Katie is training for. She made mention that she's been training for about a year on these robots. And this is the small robot that helps the astronaut. And then there is also a larger arm that is currently on Space Station.
Now, this robot will be added later is our plan right now.
That is correct.
In a few years, right?
In 2005, and Katie may be the one that's operating this robot to do space station maintenance. And here are the two big arms that Katie was talking about earlier. On your left, you have the space station arm, and on the right is the arm from the shuttle. So it's doing an assembly sequence on Space Station.
Now, Lucian, how long have you been here?
I've been here about 10 years. I've worked pretty much all of Space Station.
I've worked all Space Station too, about 10 or 12 years. We've been working at least from about the early 90s on. There were some earlier studies going on, but you've worked on a variety of robots, and I think you'd like to share with us some of the things we're going to do for the future, right?
Yeah, and this was a question that was asked by Kathy from Dr. V's class at Draper Middle School. Tell us about the new robots that you are developing. And Kathy, I brought a videotape just for you. Here's some of the new robots on your screen that we're developing. This is called AirCam, and it's basically a mobile camera. And it's there. We're developing this for Space Station, and we're proposing this to help out the astronauts. And as you see it fly out the can, it's coming to give the astronaut another view. And what this will do is this will allow the crew members inside of Space Station to help the astronauts that are outside of Space Station. And it also will do inspections. We had many questions about the space trash, let's call it. Well, if space trash hits one of the solar rays, we need to be able to inspect it. And we will be able to go out there with this type of device and inspect it.
Looks like a soccer ball.
Yes, it looks very much like a soccer ball and is about the same size as a soccer ball. And this is the most advanced robot in the world. This is called Robonaut. And this is also to assist astronauts. As you can see that, the Robonaut right now, and this is one of the tools we use to design robots, just like animation you see on cartoons. Here it's helping put the foothold for the astronaut, and then the astronaut's going to come along and work.
That's pretty amazing stuff, isn't it? Now we hope to eventually put a robot like that on Space Station as well to set up the spots for the astronauts. Look at this. This is actual real stuff, isn't it?
And this is in our laboratories that we're developing. We've taken it from the animation to the real thing. And these are just simple things like cutting strings and the like.
Well, thank you so much, Lucian Junkin. Appreciate your being here. Thanks for being on our program. Kim Willis, thank you very much for being here as well. And I believe, Patricia, I just want to thank you and everybody else for being on the program with us. And I know it's been a pleasure for me as well.
Well, thank you, Phil. It's been great having you on the show and your speakers from over at Johnson Space Center. A special thank you to you. And we want to send a special thanks over to Building 9, to Erica and to Katie Coleman and all of the folks over there who have been helping make this show so cool. And this is a thanks to Ball State, Project View, Best Buy, all of the folks who made this program possible. We've had a great time here at Space Center Houston in the coolest classroom in the world. And we appreciate all of you phoning in, sending your emails, and have a great day and go out there and experiment and have fun. Thanks. Bye. A couple of minutes after we landed, we decided to play a game of Throw the Rock. One of my crewmates threw the rock as hard as they could, and it went a mile before landing. Then when we found the rock, it was in a huge crater. I'll write to you tomorrow, Mom. Sincerely, Sarah. Dear Mom and Dad, one of the things I thought was pretty cool was the crater that had a smiley face in it, which was made of smaller craters. One thing I learned was that traveling in the car was harder than walking because when you drove, you would bounce around because it was very rocky on the surface. Love, Aaron. We also discovered life on Mars. I expected little green aliens, but it was very small bacteria-like form that we found. It was very exciting finding life on Mars, even if it was bacteria, considering that water probably didn't exist on the surface of Mars long enough for anything other than very small bacteria forms to develop. Being up at such a high altitude is really different than being on Earth because you're looking back at the outside of Earth. I made a snow angel in the polar ice caps just to amuse myself. The snow felt like slushy ice. Well, Mom, I guess I'll see you on Earth. Take care. Love, Isla.